Oh, I'm doing fine, other than my dog is barking continuously. Hopefully he won't bother us too much. She won't bother us too much, excuse me.
Oh, that's not a bother, believe me.
Okay, let's see. We left off on page 307. Number 15. So let's pick up with 16. I'm just going to shut off my camera
Okay.
right away.
I'm going to say in this case it can't be determined.
Yeah, it certainly looks straightforward enough, and that's correct. That's so straightforward that it makes you wonder if there isn't some trickiness.
Crap.
Yeah.
And once again, I don't think it can be determined.
Well, have a look at this. I write it out. I have 22 plus 28 plus x plus y equals, divided by 4 equals 15, or therefore equals 60. And implies that, think about this for a moment. I'm trying to read their answer. The answer is B. Just one moment, Angela.
Okay.
60 equals 60. I think they have a misprint in here. Well, what does x plus y have to equal? 10. And if x is positive, y could be positive or negative. This is not, I didn't get a chance to look at this one earlier, and I think the book actually has a misprint. They're saying that the answer is B. They're saying that y has to be negative, but it looks to me like if x is greater than 0, y could be positive or negative, based on this last equation here. Let me see what I did. Okay, I wrote it wrong. It's 38. Okay, so now x plus y has to be equal to 0. And since x is positive, y has to be negative. Since y is negative, quantity b is greater than. Okay, did you get that?
No, I don't. No.
Okay, let's start. It probably was because I was so confused on the whole thing. That's what this statement means. If we
Okay.
solve this for x plus y, we get x plus y has to equal 0.
Okay.
Okay? And now, since they've told us that x is greater than 0, well, that means y has to be less than 0.
Okay.
Okay? Since y is less than 0, that makes quantity b larger.
Okay.
It's amazing what happens when you make one little error in copying something.
I do that a lot.
I do too, and boy, sometimes it just leaves you completely befuddled and confused.
It does.
Okay.
Okay, quantity B would be bigger.
Correct. 19. Oops, hold on. Okay.
And I'm going to say quantity A would be bigger.
Okay. Because the 0 can merely bring it down.
Right.
Hold on. Got to use my mouse for this one. Okay. This one seems a little familiar too. I wonder if they don't take some of these questions and put them on their practice tests directly.
I wonder, because it does look familiar.
So how can we express the quantity on the left?
It'd be x plus y divided by 2.
And the quantity on the right?
X plus y plus 2y divided by 3.
Well, let's break. And now I don't remember this. It wasn't exactly this one because I don't think. The next thing we could do algebraically. I'm not sure it'll help. Let's see. Split it into partial fractions. And we have y is greater than 0. Let's try some numbers. It's not, let's see if it's apparent to me which is bigger. This part is bigger than y over 2, but x over 3, we don't know whether it's bigger than x over 2 or not, since x could be positive or negative. So I'm inclined to say we can't tell.
That's my inclination too.
We could go with that, but if I'm not 100% sure, then I would want to plug in some numbers, some simple numbers. Let's let x equal 2 and y equal 4. This might be more trouble than it's worth. 2 plus 2 over there, and 2/3 plus 4, so this is bigger. Let's let x equal 1,000,000 and y equal The reason I chose 1,000,000 is to guarantee that this quantity would be significantly larger than that quantity.
Okay.
And you can tell that this is going to override everything, and 1,000,000 divided by 2, the left side is going to be bigger than 300,000 if y is still 4. So right there I found two cases, one where the right side was bigger and one where the left side was bigger. And that's all I need to know.
Okay.
Let me just see what they have to say about this problem. If x is less than y, then the average of x and y is less than y, and surely less than 2y. So 2y has to raise the average. On the other hand, if x is much larger than y, then 2y would lower the average. That's kind of the two situations that I came up with. So, and that was a little harder than normal problem. All right, let's see. What do we have for the next section here? Good. Polynomials. 317. Blurry polynomials. I may have to upgrade to an iPhone or something with a little better camera. My camera is only 5 megapixels. All right, on this first one, can you read that?
I can.
Okay. And tell me how you're doing it.
Factoring
Okay.
a squared minus b squared.
Okay. As opposed to, you could plug in 117 under the calculator and go through everything. But that would be the harder way to do it. It's going to be easier if you know how to factor that quickly. It'll be easier doing it this way. And it's a plus b, 235. Okay.
I'm assuming to once again factor, let's see, to figure out what a and b are.
Since I'm not sure we're going to be able to tell. So if we have a minus b times a plus b equals 21, this one doesn't factor. The sum of squares is not factorable. Which of the following could be a value of a times b indicate all possible values? Let me think about this for a moment. How are we going to come up with an a times b?
I'm not sure.
What if we solve for a and solve for b and come up with it that way?
Okay.
Two equations and two unknowns. Not only that, they're given to us in standard format like this. So I can readily solve for a and then I could go back and easily solve for b, and then find the product. So what's a equal to?
2a squared.
Well, if I add these two equations, I get 2a squared equals 50, which makes a squared equal to, help me out here, what's the
A squared equals 25.
Okay.
And so a is going to be 5. Or, yeah.
Plus or minus 5.
Okay.
And that's going to be important because they're asking about a times b. And notice they say all possible values. So if you would have neglected the plus or minus, you would have only come up with one possible value. And then you should kind of ask yourself, well, I must have kind of gone wrong somewhere. So if we now go back and solve for b, I can take the second equation and subtract the first equation from it to get what? In other words, if I call this equation 2 and this equation 1, and I start with equation 2 and subtract equation 1, what do I get?
Okay, you end up with 2b squared equals 50. So it's going to be the same thing.
Equals 8.
Oh, yeah, I added them.
I'm subtracting them. That's okay. You don't have to subtract them. We could go up here and multiply by -1 and then add them. It just kind of saves a step by subtracting them instead of adding them. So what is b equal to?
Plus or minus 2.
So we got a equal to plus or minus 5 and b equal to plus or minus 2. So can their product be minus 10?
Yes.
Can it be 5 root 2?
No.
But it can be 10.
Yes.
Okay. Now there was a question. I think I told you that we're going to run into a problem where if you don't include the plus or minus, it will cost you. All right, what's the average of, well, let me write that out. It'll be a little clearer. We know the average is going to be the sum divided by 3, correct?
Yes. Yes.
Notice I don't use parentheses, no need to if I'm adding everything. If I was going to subtract anything, I would need to, but okay. So let's simplify the top, which is, where do we start here?
And you know, I'm coming up with 24 divided by 3.
Answer E. Very good. Everything cancels except the numbers, huh? Yep. Okay. What's the value of x squared plus 12x plus 36 when x equals 994?
Huh.
Yeah, that's what I just said. Well, there must be an easier way to do that, this problem. Without further thought, I don't think they really want you to plug that into your calculator, although that might be the quickest way to come up with the answer. Did we determine yet whether you're going to be, well, you can square stuff by just multiplying it by itself. it's probably going to be helpful to recognize this as x plus 6 squared. Notice how much easier that makes the problem.
A lot easier.
Because now we have 1,000 squared, which is what? Now, is that one you need to use the calculator on, or can you do that in your head? You just double the number of zeros.
Okay.
Okay. In other words, that's the same as 1,000 times 1,000, which is 1,000,000. In other words, you always have the number of zeros in your answer as the total number of zeros in the two products. In other words, 10 times 100 is going to have 3 zeros in the answer.
Okay.
Okay. Not sure how much time was saved by recognizing that that was x plus 6 squared, because
I think a lot.
well, without calculators, a whole lot. And this would have been an excellent problem for the old GRE, because you would have almost had to do it that way. It would have been real tough manually to stick in x equal 994. In fact, this would have been a great problem, and they've turned it into a mediocre problem by allowing calculators. You can't tell I'm biased or anything, can you? This looks familiar.
Yeah, just add them.
The only difference between this and the previous problem, or the other problem, is that this has a binomial being squared. So it's not the same thing. The previous one had c squared plus d squared and c squared minus d squared. This, if we expand it, is what?
C squared minus 2d squared.
2cd.
Yeah, geez.
Plus d squared. So that's equal to 2. And then we have c squared plus d squared is equal to 4. So we can come up with a value of CD very simply here by subtracting them. Now, I didn't really write them in the best possible order. I should have wrote them in the order they were given to us, with this being number 1 and this being number 2, and it makes it easier to see that we should subtract 2 minus 1. What do you get when you subtract equation 2 minus equation 1?
Sorry, I'm still reading it.
Okay.
You get negative, or you get 2CD equals 2.
Okay. So in that one, we didn't have to solve for C and D. Like in the other one, we had to solve for A and B to answer it. In this one, we were able to solve for CD as a product directly.
Okay. Okay, on this one I would just add them. Add and, well, you know, subtract, add and subtract.
Well, you got to multiply this binomial times this binomial. So you'd have to FOIL those. And you'd have to FOIL these. And the only difficulty is going to make sure that you put this answer in parentheses so this negative sign here gets distributed properly.
Okay.
Okay. However, this is another one of those problems where that's a lot of work, and that may be what they're looking for. I did notice something by quick glance. This is going to produce a 2x squared, and this is going to produce a 2x squared. So my final answer has to have no x squareds in it. So I have immediately eliminated D and E.
Oh, okay.
A, B, and C. Let's see if we can eliminate anything else. Clearly all the x's have to disappear, right?
Yes.
Since I've eliminated D and E, I can't have any x's either, so I only have to worry about the numbers. The numbers are 18 minus a minus 50, 68.
Well, that was quick.
I guess. It definitely was quicker, but I always question whether it was worth the time searching for the shortcut. Because you kind of have to do a bit of mental math. You don't want to write. In other words, if you put this on paper and you start foiling it out, you're never going to spot that.
Right.
The only way to spot it is to kind of look at it and kind of do the first step in your head for this foiling and the first step in your head for this foiling, and that's when you notice a key fact, that there's no x squareds in the answer. Okay. I think it's useful to always start with what they're asking and formulate that as an expression. So what are we trying to find?
We're trying to find A plus B divided by 2.
All right. Well, if 1 over A plus 1 over B equals 1 over C, is that the same as A plus B equals C?
No.
No, it isn't. So let's go ahead and perform this addition. What's 1 over A plus 1 over B?
It's going to be BAB.
Well, it's going to be B plus A in the top over AB. Okay, let's go through that just in case you're not clear about it. Okay, I can tell my common denominator has to be AB. So in order to get an AB over here, I have to multiply it by B over B, which I'm allowed to do because that's the number 1. In order to get an AB on this term, I got to multiply it by A over A, also the number 1. And that produces B over AB plus A over AB. Now that I have a common denominator, I can just add the numerators, and I get this.
Okay.
Okay? And now notice that we've got a special thing that they're looking for, which is, oh, not a special thing, but they've given us what AB is. It's C. So I can substitute for this AB C. So first of all, let's finish that, and then I'm going to substitute C for this. So now what can I say about the numerators? In other words, I can just multiply both sides by c. If you
Right.
have the same denominators, then the numerators are equal, which means I can erase this, and I have b plus a equals 1. So what is b plus a divided by
1/2.
2? Answer B. All right, let's see. X squared minus y squared, difference of squares. And x minus y, what is the average of x plus y? So what are we looking for?
X plus y divided by 2.
Okay. So what can we do here? When you see difference of squares, it's almost always that you have to go ahead and factor that.
Okay.
Especially when they give you one of the factors in the very next sentence or in the next part of the sentence. So if I factor x squared minus y squared, I get x minus y times x plus y. And if that's equal to 28, and then they tell us that x minus y is equal to 8, then x plus y equals 28 divided by 8. And I'm looking for x plus y divided by 2. Now here, what would you do for x plus y divided by 2?
Divide both sides by 2.
Okay. So do we have to do that in math, or can we look at our answers and tell what the answer is? Again, that's another trick that you don't really need to employ anymore. Since you've got a calculator, you can come up with 1.75. What I would have done was said, well, 16 is greater than half of 28, so the answer has to be less than 2.
Okay.
There's only one answer on there that's less than 2. All right. So I need the next page here. Hopefully I took a better picture of this one. I did. Amazing. What a steady hand. Oops. That's right. Again, it's probably worth looking for a shortcut.
Well, we know that the 1 divided by a is going to go, well, actually, I don't know, it's squared.
You're right. You're absolutely right. In other words, the way you need to think about this problem is what is a plus b squared and what is a minus b squared? Remember that the differences are only in the middle term. Consider this a plus b, consider this a minus b. If I subtract them, the a squareds go away, the b squareds go away, and I only have the middle term to worry about. So what is the middle term in this case? And in fact, you can tell that your answer is 4AB.
Right.
So what is 4AB equal to? What is A times B equal to?
I'm lost.
Okay, it might be because I tried to do a shortcut instead of actually multiplying it out. When I pointed this out over here, I was trying to indicate that we could let A equal this term here,
Okay.
and B equal this term here. And then we would have the situation A plus B squared. And over here we would have A minus B squared. I apologize for using the same variables. I probably should have used X and Y over here, and then it wouldn't have been as confusing. But regardless, if I take this and subtract this, it's the same as taking this and subtracting that. And when I do that, the A squared terms disappear, the B squared terms disappear, and I'm left with 4AB. So that's going to be my answer, but the A was actually 1 over A, and the B was actually A.
Oh, okay.
So the answer would be 4. Now, I pointed this out because I think this is a huge concept that you need to be able to square an A plus B no matter what it is. In other words, it doesn't have to be A plus B. It could be 2x plus 3y. Square that for me quickly.
4x squared plus 6xy plus 9 squared.
Remember, it's 2
9y.
It's 2 times the 2 A and the B. So it has to be a 12xy in the middle plus 9y squared. Okay?
Okay.
Okay. So in this case, I'm not sure that shortcut is necessarily worth it, because if you expand this, what do you get? 1 over A squared plus 2 times A over A plus A squared. You would quickly realize you're going to get 2 minus a minus 2. So you'd still come up with 4.
Okay.
But I do think that they did intend the shortcut here to have you recognize that this is just an x minus, this is an x plus y squared minus an x minus y squared.
Okay.
It's just the x is 1 over a and the y is a. I'm not going to leave us alone with this 1 over a. Okay.
Isn't, let me see.
Probably the easiest thing to do is go ahead and expand that.
Okay.
What do you get?
I can't do it as fast as you. I actually have to write it down, or.
Okay, no, that's fine. I didn't mean to rush you.
Oh, that's okay. So it would be 1a squared.
1 over a squared.
Yes, 1 over a squared plus 2a. No.
How about that? In other words, what it really is 2a times 1 over a. right? Plus a squared. So that's what's equal to 100. Did I lose you?
Yeah.
Okay, remember the middle term is 2 times this term times this term. So that's where I got the 2 from. And then the one term was a, and the other term was 1 over a.
Okay.
Okay, so that's our middle term, and then the end term is a plus a squared. Well, they're asking about the sum of this plus this. So if we can figure out what this is, we'll know.
Okay, and that's 2.
Okay, so the sum of the other two is what?
98.
Yep. Okay, and that was a case where you really do need to know how to FOIL that out in order to answer the problem. Now, it doesn't necessarily mean you had to have that memorized, how to FOIL it. You could have FOILed it outright using, FOIL. But in general, I think it speeds things up if you have that memorized.
Okay.
N is less than 0.
I'm going to say they'd be equal.
Notice that the exponent on the left side does not apply to this negative sign.
Right.
So 2 times n squared is going to be positive no matter what. Whether n is less than 0 or not, this will always be a negative number.
Okay.
This, on the other hand, the 2 exponent does affect the negative sign. So this will always be a positive number, regardless of n.
Okay.
So quantity B is larger than quantity A without that.
Yeah, no matter what.
Yeah, it's another one of those kind of irrelevant pieces of information that I think, unless I'm missing something here. Let me just look in the book and see. Yeah, it's exactly. They didn't mention the fact that they had put irrelevant information in there, but.
I'm going to say that quantity B is greater.
Okay, and how'd you do it?
Well, I FOILed both of them.
Okay, so we got c squared minus d squared, and you don't need to FOIL that if you recognize it as the factoring of difference of squares. It comes out immediately as c squared minus d squared. Right. This one has the c squared plus d squared plus the middle term. Now, if d is less than c, then this has to be positive. This if C or D is negative, this might be negative. I could think of a C and a D that would be negative. Boy, I don't know. The fact that C squared plus D squared, even if C and D was negative, we'd be adding a pretty big positive number to it. What if I had D being... So what was your reasoning once you got to this step? How'd you determine that?
Well, I was just thinking, maybe I wasn't thinking, that because we had the negative 2CD quantity, that that was going to make it larger.
Well, we've got two problems. First of all, this is not the C squared plus the D squared term.
Right.
If it was C squared minus a D squared over here, then we could think only about the middle term. But since it's C squared plus D squared,
Right, they're not equal.
I'm not sure. Let me think a moment about this. If we go back and look at the original problem, notice that if this was an equation, and we can kind of think of it as such, I can factor out the C minus D from both sides. So really what I'm comparing is a C plus D compared to a C minus D, right?
Uh-huh.
Okay, and if I know that D is less than C,
then quantity A would have to be larger.
yes.
Okay.
Even with negative numbers? What if D, let's just check negative numbers to make sure.
Okay.
Let's try a D of minus 4, whoops, a D of minus 4 and a C of minus 3. So that would add to be minus 7, and yet minus 3 minus a minus 4 would be plus 1. B would be bigger.
So it can't be determined.
Correct. Let me check their answer. It cannot be determined. Now, oh wow, I didn't take the next step, the next obvious step, which was to say that if C plus D compared to C minus D, we will just cancel the C's also. So now I'm really comparing D with minus D.
Oh, okay.
And it doesn't really matter that D is less than C. It only matters that if D can be positive or negative, I can't tell which of those is bigger. It is actually much easier to analyze once you do eliminate everything and you're comparing D with minus D. Yeah.
That did make it a lot easier.
I think it does, yeah. That's the way they did it. They got it down to D and minus D. But the thing that it kind of illustrates here is that the way you solve some of these comparisons is by treating them as an equation, dividing both sides by C minus D, and then dividing both sides or subtracting C from both sides. Even though it's not technically an equation, we don't know if it's equal or not, you can treat it like that in terms of trying to compare quantity A with quantity B, to whittle it down, so to speak.
Okay. Well, let's see, since the negative Oh, but it's a negative negative. So I'd say quantity B is larger.
Correct. Because again, this negative sign is not squared. So even though we're going to square a negative, and this part will be positive, we still have to apply this outside negative.
Right.
As long as y is positive, then we're always just going to have one negative left. Oh, I haven't seen this problem in a long time. This is a cool problem. Last time I saw this problem was on a SAT prep test, and it was the exact problem, R's and S's.
Can we use the distributive property on quantity B?
You can, but you won't like it.
Okay.
That's what's clever, and that was exactly the way it was on that SAT test, is that if you went that way, you'd find yourself in a forest full of trees not being able to see out. But you kind of have to recognize something else. I guess you have to. I'm trying to think if there's any other methods to solve this. Notice what happens. It's worth talking about here because this is such a clever problem. That's what you get if you distribute those. That's what you get if you FOIL the left. Okay, this would work. This would work. Now what?
Cancel.
So we have r squared minus s squared on the left, and we have r squared minus s squared on the right.
Correct, so they're even.
Correct.
Equal.
And that really didn't take long. There is an interesting principle here that was far more important on the SAT problem that I did, where if I said simplify this by factoring, what could you factor out? We're used to factoring out single terms, but there's nothing that says you can't factor out a binomial. Notice that this binomial is the same.
Right.
I could factor it out, r plus s, and what's left behind? R minus s.
Okay.
So I immediately get there and can see that I've got the same equals the same.
Okay.
But didn't need to be able to do that because it was certainly readily solved by FOILing it out. But that might be a useful principle to know.
Yes, it is.
You can factor out binomial terms.
Well, in this case, it looks like x can be anything.
When I first looked at this, it looks like a factoring problem. Problem is, yes, it is a factoring problem. Factor the numerator.
Well, we can take 5. Yeah, x squared minus 20 up 4.
Okay, now
I'm writing it down and saying, looking at what's on the screen and saying there.
that's okay. That's okay. And then factor it again, because now we're looking at the difference of squares.
Right, x plus 2, x minus 2.
And what we were looking for was that x minus 2, because that's being divided. So this is 5x plus 10. This is 4x plus 8.
So A is bigger.
Not if x is negative.
Okay.
Or not. Hold on a second. Maybe it is. 5x plus 10. We'll put an equal sign in there. Just if x is equal to minus 2, they're equal. In other words, I equated them and then solved this equation. So if x happened to be equal to minus 2, they're even, and yet we can clearly see that with any other number, one is larger than the other.
Oh, okay.
So we can pretty much immediately assume that it can't be determined.
Okay.
But the way I initially did it is a good way to do these, because you don't want to forget the negative realm of numbers.
Right.
Because that will frequently make a difference, especially on these direct comparisons more than anything else.
Okay.
Should we stop at 15?
Yes.
Seems to be, we're keeping up a pretty regular pace here. It's pretty amazing, actually, that we've gotten through question 15 like 4 straight sessions.
Oh, well, I'm glad.
And we're not doing 15 problems. We're actually doing 20, because we're only halfway through this section. We've still got a 16 through 20. So we're actually doing 20 questions a session, which is a good pace.
Which is good, because I need all the practice I can get.
Yeah. Okay. I will, let's see. That's the last session for this week. I don't have my calendar up.
Yeah, I was going to say, I haven't scheduled any more yet, but I'm going to do that as soon as we end this session.
Okay, sounds good. And like I said, if you have any difficulty with scheduling, I can almost certainly make the 10 o'clock hour available if a 9 o'clock hour is not available to your suiting.
Okay.
Okay?
Okay, thank you.
All right, Angela. Have a good one. Talk to you next week.
You too. Bye-bye.